Friends, today we are doing the modern periodic table. This chapter is common for 8th, 9th and 10th. So this is a general revision of this chapter in short. So let's begin the chapter. Let's understand what is an atom or an element. दोनों को हम लोग interchangeably use कर सकते हैं. Atom और element दोनों को same interchangeably हम दोनों को बोल सकते हैं. So atoms जैसे कि for example hydrogen, helium, lithium, boron, beryllium, carbon, nitrogen. तो पास्ट में ऐसे बहुत सारे एटम डिस्कवर हो रहे थे, पीपल वर इंट्रिग्ड और रुदरफोर्ड के एक्सपेरिमेंट के बाद काफी साइंटिस्ट की वजह से हमने एटम का स्ट्रक्चर समझा. सो आई एक्सप्लेन दैट स्ट्रक्चर इन डिटेल. लेट्स टेक एग्जांपल ऑफ सोडियम. तो सोडियम एटम बनाता हूं. तो एटम के सेंटर में एक न्यूक्लियस होता है. फिर एटम के न्यूक्लियस के अराउंड होते हैं उसके ऑर्बिट्स, जिसे हम शेल्स भी कह सकते हैं. So these are the shells of the sodium atom. Now nucleus contain two things. The two things are protons and neutrons. Positively charged protons or no charge वाले neutrons. So this positively charged are called as protons and no charge are called neutrons. Neutrons have no charge. और ये दोनों heavier particles होते हैं compared to the third thing that is present in an atom, that is electrons. तीसरी चीज जो एटम में होती है वो होते हैं इलेक्ट्रॉन. फर्स्ट शेल में 2 इलेक्ट्रॉन होते हैं, सेकंड में 8, थर्ड में 18, फोर्थ में 32. By this formula 2n square. n मतलब कौन सी शेल? पहली शेल, दूसरी शेल, तीसरी शेल, चौथी शेल. So you can put 1 2 3 square it multiply by 2, you get the number of shells. के अंदर कितने इलेक्ट्रॉन्स फिट हो सकते हैं? So these many electrons can fit in the shell. First shell only 2, second shell 8, third shell 18. So तीन चीजें एटम के अंदर मोस्ट इंपॉर्टेंटली होती है: प्रोटॉन्स, न्यूट्रॉन्स एंड इलेक्ट्रॉन्स. प्रोटॉन्स आर पॉजिटिवली चार्ज, इलेक्ट्रॉन्स आर नेगेटिवली चार्ज, न्यूट्रॉन का कोई चार्ज नहीं होता है. और हमेशा प्रोटॉन और इलेक्ट्रॉन्स की क्वांटिटी सेम होती है. दे आर इक्वल. दे आर इक्वल. सो नंबर ऑफ प्रोटॉन्स. सो दैट इज व्हाई वी हैव टू अंडरस्टैंड द नेक्स्ट डेफिनेशन फर्स्ट हियर. एटॉमिक नंबर क्या होता है? एटॉमिक मास नंबर क्या होता है? एटॉमिक नंबर इज नंबर ऑफ प्रोटॉन्स और इलेक्ट्रॉन्स. क्योंकि दोनों सेम होते हैं तो प्रोटॉन्स और इलेक्ट्रॉन. जैसे कि सोडियम के अंदर एटॉमिक नंबर है 11. सो सोडियम हैज 11 protons and 11 electrons. So दो इधर, 8 इधर and last में 1 because 2 8 is 10 and 1 last one. Last shell is only 1 electron. So sodium का इलेक्ट्रॉनिक कॉन्फ़िगरेशन ऐसे लिख सकते हैं 2,1. And atomic mass of sodium is 23, which you have to remember. So protons कितने होंगे? जितने इलेक्ट्रॉन्स. इलेक्ट्रॉन्स कितने हैं? 11. Protons will be 11. So neutrons will have to just subtract this. 23 minus 11 is 12. So 12 plus 11 is 23. So sodium के अंदर 23 electrons, sorry, protons and neutrons होते हैं, electrons 11 होते हैं. So this is the structure of sodium which you have to remember how to make it and what exactly is atomic number and atomic mass number. Atomic mass number और atomic number अगर आपने क्यों समझा? Because all the scientists which are classifying elements, ये सब elements को जो classify करने की कोशिश कर रहे हैं, they are trying to classify on the basis of their atomic mass number. So this chapter we are going to study about history. कैसे scientists ने atoms और elements को classify करने की कोशिश की, because as the atoms were discovered, तो 10 atoms it's okay, we don't need to classify them. 50 atoms I want to classify them. 100 atoms I need an order to identify my atom where it belongs. तो इसीलिए 1817 से ही क्लासिफिकेशन स्टार्ट हो गया था. द फर्स्ट क्लासिफिकेशन वाज मेड बाय डोबेनार. सो डोबेनार क्लासिफाइड देम इन अ टेबल ऑफ 3. ही मेड अ सिंपल टेबल of 3 and he classified all the atoms. So for example, first he classified lithium and potassium. So what was Dobenar law of Tri? Dobenar law of Tri, it is that the atomic mass of the middlemost element is average of the first and the third element. Atomic mass of middle element can be calculated by taking an average of these two. So lithium का atomic mass है 6.9, potassium का 39.1. Atomic masses were known. He calculated them. So 6.9 plus 39.1 is 46. Let's divide it by 2 because we are taking an average. So it comes out to be 23. And we have seen 23 is the mass of sodium. So he placed sodium in the middle. So that's how he classified all the elements. तो ऐसे काफी atoms का average आ रहा था. We were adding these two together and getting an average, but after classification of certain set of elements, this average was not coming. So that is why Dobenar's law of triads was rejected. So after 30-40 years, people were still doing research and trying to classify them. In 1866, Newland tried to give his law. So Newland gave his law of octaves. Octaves का मतलब होता है 8. So like in music we have 7 musical notes, 7 sur, and the 8th one is the repetition of the first one. So with the same logic, Newland made a table of where he classified them in a group of 7, and the 8th one having a similar property to the first one. That was the Newland law of octave. He arranged them in the order of a musical notes in which the first element had a similar property to the 8th element. So Newland के अंदर we have to study its law, how he placed them, and its demerit, why his law was rejected. So his law was rejected because he was only able to classify 56 elements known at that time. Later on when elements were discovered, he was not able to classify them. First demerit. Second demerit is of cobalt and nickel. He placed them together. There were many examples that he placed them together because he could not arrange them, so he placed them together. So second demerit is he placed cobalt and nickel together. He also placed cesium and lanthanum together. Another example, if you want to give, cobalt and nickel is famous example because you can add one more disadvantage, that he placed them in the first group itself. First group में उसने cobalt and nickel को place किया था, and the first group he placed hydrogen, fluorine, chlorine and bromine. So all the elements, these are halogens, these are having one shell in the outermost shell, one electron in the outermost shell. Cobalt and nickel की properties बिल्कुल अलग थी. So that is the disadvantage. He placed them in the first table and the properties were completely different. So तीन demerits आप बोल सकते हो. Cobalt and nickel were placed together. Their properties did not match with the first group elements. So the third try was done by 3 years later on, very close to Newland, the same time period. Mendeleev was also doing his research. So Mendeleev was a Russian scientist and he classified in a huge table. He did not want to classify in a group of 3 or 8. He said we need a huge table having 8 periods and 8 groups and 20 periods. He placed them in a huge table. So there are many merits of Mendeleev. So the merits which are marked there. First merit of Mendeleev is that he left vacant spaces. Mendeleev was smart. He knew that some elements are not yet discovered and they are going to be discovered. So he left vacant spaces for that element to be classified, and the famous example is eka boron, eka aluminium and eka silicon. Eka boron, eka aluminium, eka silicon, which was later discovered on to be scandium, gallium and germanium. Remember this example? So he left vacant spaces for certain elements and they were later on discovered, and the properties also he predicted. एक और point डाल सकते हो, अगर आप properties याद कर सकते हो. So he predicted their properties and those properties were exactly same what Mendeleev predicted. Second merit of Mendeleev is that he corrected many atomic masses which are wrongly calculated. For example, beryllium was considered to be 14.9, but it was 9.1. So Mendeleev corrected it. So Mendeleev corrected many atomic masses which was wrongly calculated. And the third merit, you can say that when noble gases were discovered, so without disturbing the table, we can place them in the right hand corner easily without disturbing the table. So Mendeleev periodic table was working on, it was working, and it has many merits, but there were many demerits. The first demerit is what he did, what everyone did, atomic mass. He classified them according to atomic mass. So because of which there are many demerits. First is there is no place for isotopes left. Because atomic mass से cover कर रहे हो तो फिर हर आइसोटोप को डाल नहीं सकते हम उसमें. Isotopes क्या होते हैं? Atoms having same atomic number but different atomic mass number. मतलब उनका atomic mass ज़्यादा होता है. जैसे हाइड्रोजन के 3 आइसोटोप्स हैं, तो तीनों की 3 आइसोटोप्स है, cannot place it here. क्लोरीन के 2 आइसोटोप्स हैं. All the elements have isotopes. सब आइसोटोप्स को place नहीं कर सकते. There is no place of isotope. The second demerit is fixed position of hydrogen. Hydrogen को first period में fixed position दे दी थी Mendeleev ने, which was not supposed to be given. Hydrogen is not a metal. पहले ग्रुप में सारे metals थे. Hydrogen is not a metal. So fixed position of hydrogen was wrongly done. And third, he wrongly placed cobalt and nickel. He was placing them in the according to their properties. So properties के हिसाब से, but atomic weight के हिसाब से he was placing them. So cobalt and nickel का atomic weight आगे पीछे हो गया था because he had to place them according to the properties. So cobalt and nickel were placed in a wrong manner. So cobalt and nickel का demerit you can write. So because of all this demerit, even Mendeleev's table was discarded, and now we come on to the modern periodic table. So finally, Henry Moseley, after again 20-30 years, Henry Moseley was doing his research. So Henry Moseley in the 19th century he gave us the modern periodic table. The modern periodic table I'm going to draw it in short. How does it look like? It looks like something like this, the modern periodic table. So modern periodic table में क्या क्या होता है? Modern periodic table में this is the first and the second group. This is 3 to 12. This is 13 to 17 and the 18th group. Just like mentally placed it in the right hand corner. Mostly did the same thing. He placed it in the right hand corner. So 18 group होते हैं modern periodic table में, 18 groups and 7 periods. 7 periods. ये 6th और 7th period का continuation है यहाँ पे. Lanthanum and actinium because it's a very long period having 36 and 38 elements. तो यहाँ पे 36 elements को place नहीं कर सकते, तो यहाँ से lanthanum और actinium से extra elements are placed down. And these are 4 blocks also. This is S block, this is P block, this is D block, this is S block. 4 blocks से भी classify कर सकते हैं. ये subshells के ऊपर based है. Subshells, it's a difficult topic that we will cover in some other video. Subshells के हिसाब से classify किया था. So these are metals. The first is alkali metal. The second is alkali earth metals. These are known as transition elements. Transition का मतलब the change. So they are having a transition from metallic character to a certain non-metallic character की तरफ जा रहे हैं. 13 to 17 are non-metals. बीच में zigzag shape में metalloids भी हैं. There are metalloids placed in the middle here. And 18 group, as we all know, they are noble gases. 0 group elements we can call them, and these are lanthanides and actinides as I told you. So this is important. And group 17 also here is important, known as halogens. The famous halogens: fluorine, chlorine, bromine, iodine and acetylene. So these are famous halogens. So alkali metals, alkali earth metals, transition elements, non-metals, metalloids, noble elements, noble gases and F block elements. So this is the modern periodic table, how it looks like. अब इसके अंदर जो main properties हमें पढ़नी है, इसके trends पढ़ने हैं, which can come in the examination. जो famous answer आता है about atomic radius and the metallic character. So the first trend that you have to study is about atomic radius. What is atomic radius? Atomic radius is the distance from the nucleus to the farthermost shell. जो outermost shell होती है उसके बीच से जो radius होता है, that is known as atomic radius. That is the size of an atom. So in the first period there is only one shell. In the second period there are 2 shells. Third period there is 3 shells, and so on. So 7th period will have 7 shells. 7 shell होगी. So as you can see, shell is increasing, size is increasing. So from top to bottom in a group, and from top to bottom, the atomic radius is obviously increasing. Now let's see about in a period how it happens. Left to right कैसा होता है? So let's take example of second period. सबके पास 2 shells होगी. सबके पास 2 shells होगी. But the number of electrons is increasing. पहले वाले के पास 1 इलेक्ट्रॉन, इसके पास 2, 3, 4, 5 and so on. Number of electrons are increasing. So if the number of electrons are increasing, what will happen to the number of protons? They will also increase. So अगर प्रोटॉन increase होंगे तो क्या increase होएगा? Nuclear pull is going to increase. So nucleus is going to pull more. So as you move from left to right, the number of electrons increases in the same shell, and the nuclear pull also increases. So because of which, what happens is the atom shrinks in size. So therefore the atomic radius decreases. So from top to bottom it increases, from left to right it decreases. So this is what you have to write if it comes as a give reason, or it can come as an explanation. So you have to explain that from top to bottom it increases and from left to right it decreases. Now moving on to the next important characteristic, that is metallic character. Metallic character के साथ कैसे होता है? Metallic character के साथ it happens exactly opposite. It increases from left to right because metallic character depends on one phenomenon which is known as electropositivity. Metals कौन होते हैं जो easily electron lose करते हैं? That is electropositivity. How easily an atom loses its electron? जैसे कि सोडियम का हमने एग्जांपल देखा था, लार्ज शेल में सिर्फ एक इलेक्ट्रॉन था, तो न्यूक्लियर पुल बिल्कुल नहीं होगा. It is easy to lose an electron. Sodium will lose its electron easily. So sodium is metal. It's a very good metal. सोडियम के ऊपर होता है lithium. That is the most एफिशिएंट मोस्ट बेस्ट मेटल टू एग्जिस्ट, लिथियम सबसे ज्यादा मेटालिक कैरेक्टर लिथियम का है, सोडियम के भी ऊपर इट कैन मोर इजीली लूज इलेक्ट्रॉन कंपेयर्ड टू सोडियम. So that is electropositivity, the tendency of an atom or an element to lose an electron. So it's easy for him to lose an electron, but as you move on it's get difficult to lose an electron. Instead they will be accepting electrons, क्योंकि उनके पास शेल के अंदर 5-6 ज्यादा इलेक्ट्रॉन है, तो they will be accepting electrons. So that is why they are non-metals. So metallic character decreases because of electropositivity, it decreases. And top to bottom में कैसा होगा, again it increases just like atomic radius increase होता है, तो उतना ज्यादा इजी होता है इलेक्ट्रॉन को लूज करना, उतना ज्यादा इजी होता है. तो therefore the element placed here is the most metallic element in the modern periodic table, because for him it is to lose the electron is the easiest. I think it's francium, the seventh period, the last element here, which is the most metallic element. So this is about electropositivity. Electropositivity के वजह से metallic character decide होता है. What is electropositivity? The tendency of an atom to lose an electron. जितना easily lose करेगा उतना ज़्यादा metal होगा. So top to bottom it's easy to lose an electron, so therefore it increases just like atomic radius. Left to right it gets ulta, because atomic radius decrease होता है, but metallic character भी decrease होता है, because it's not easy for them to lose an electron. So that is why metallic character also decreases from left to right, and top to bottom is increases just like the atomic radius. Moving on, the next important thing that you have to understand is what is electronegativity. So जो जैसे हमने electropositivity में पढ़ा था, electronegativity exactly उसका opposite है. Electronegativity is the tendency to accept an electron. So as we know, these are least electronegative and these are the most electronegative, because it is easier for them to accept an electron. So electronegativity is the tendency of an atom to accept an electron. So these are the most electronegative. These are non-metals. जो ज़्यादा electronegative होते हैं उसको बोलते हैं non-metallic character. So it's easier for them to accept an electron, and as you move down, again it gets more easier to accept an electron. It gets less easier to accept an electron. It decreases electronegativity. So therefore fluorine here is the most electronegative element, because fluorine can accept readily, and जैसे जैसे नीचे जाता है शेल बढ़ती जाती है, so न्यूक्लियर पोल इतना स्ट्रांग नहीं होता है, तो इतना इजीली एक्सेप्ट नहीं कर सकते हैं. So therefore down it electronegativity decreases, but left to right it increases, and fluorine is the most electronegative if we intersect these two. So this is in general about the metallic periodic table के बारे में शॉर्ट में सारी प्रॉपर्टीज बता दी है. And if you have any doubts, you can comment and you can ask me on the number. You can directly contact me if you have any doubts. I will explain and make videos on a specific topic. Please press the bell button so that you know if I am posting any more videos. And if you want the lectures to be conducted, more videos to be conducted, or if you have any suggestion, please let us know.